Good morning, students. I am Vetri Chelvi from Vetri and Vetri NEET Academy. Today, let us see the topic of aromaticity. This topic is very important. Every 2 years or 3 years once the question they are asking, the NEET aims somewhere else. Okay, so make sure of the topic. Now, let us see the aromaticity rules for the aromaticity. The things are, it should be compound should be cyclic and it should be planar and it should be follow the Huckel's rule, and the Huckel's rule formula is number of pi electrons equal to 4n plus 2. That is where n is equal to integer means that compound is following the aromatic character. Apart from that, the n integer, if you substitute the value of 0, 2 electrons, and then if it is the 1 means 6, 2 means 10, 14. So these are the number of pi electron should be in the aromatic compound. Then only the compound is aromaticity. Instead of this pi electron, the trick is you can go with the, if the presence of odd bond number, that is either 1, 3, 5 mean that this is 1, 3, 5 mean that compound is containing the aromatic nature. The last very important point is the substance should have the presence of conjugate system. The meaning of conjugate system is the compound should containing double bond, single bond, double bond in alternative manner. Then only the electrons could delocalize. Pi electrons could delocalize. Or you can see double, single, triple. Anyhow, the electrons should be delocalized. The possibility is called as a conjugate system. So these 4 points are important, children. One is cyclic, planar, Huckel's rule. The electron either you 2, 6, 10, 14 pi electron, or it may be the 1, 3, 5. Is an easy way to count. We are having 1, 3, 5 odd bond number. Number of bonds equal to 1 or 3 or 5 mean the substance is aromatic. Very important point is conjugate system. Let us go to the example, children. Now let us see the first example. Here it is given as the structure planar cyclic conjugate system is delocalization of pi electron is possible. How we can say this is your positive charge is there, so the pi electrons are delocalizing towards it. So this is having the conjugate system. Number of the pi electrons are there is the 2. 1 pi bond, so this is the 1. That is number of electron is 2. Or I said 1 odd bond, so it is aromatic. Second example, planar cyclic, the bond is having only 2, that is the pi electrons are 4, or I can say the even bond number 2. So it should be 1, 3, 5. Now it is 2, so it is the anti-aromatic. The meaning of anti-aromatic, the system planar cyclic conjugate. The initial conditions satisfy, but it is not satisfy the Huckel's rule mean you can call it as a anti-aromatic. So now aromatic and anti-aromatics are over. Now let us see the next example. Now the example is 3. Where you can see the compound. This is the compound where this electron, that is the bond, negative charges involved in the resonance. This is the different planar cyclic conjugate system, but total pi electrons are here 6. So it is called as a aromatic. 2, 4, 6. So this compound is aromatic. So here same cyclic planar conjugate. By you see the counting of electron, it is only 2. So it is only the what is it? 2 electron, so of course pi electron, so it is aromatic. Now coming to the fifth example where you are having the cyclic planar conjugate, but the electrons are only 4, or I can say the bond is 2 number. It should be 1, 3, 5. It is 2 number, so it is called as a anti-aromatic. Next compound, here the structure of compound cyclic planar. What about the pi electrons? You are having the 6, so it is aromatic. So now the examples are over. Let us see them. Questions from the year aims of 2001 and 8. The previous year questions. The question is, which of the following is aromatic? four compounds are there. Which is aromatic? The compound first here the even bond is there. So it is not aromatic. Here you can see the bond. Everything is fulfilled. Cyclic, planar. How many electrons are? Pi electron mean 2, 4 and here 2 electron. So this is also involved in the bond formation. Delocalization. So this is having 6 pi electron. So it is aromatic. Whereas in the case not planar because it is here sp3 hybridization. Here what is it? Even bond. So it is called as a anti-aromatic. Now let us see the next question of the AIMS, of course 2004. This is the question of AIMS. Year is 2004. Now let us see the question structure is here same compound. Here of course even though it is the same, if it is repeating, I am giving because you should know how it is repeatedly coming mean you have to prepare the previous question is very important. For the basis I am giving it is the same compound. So what is it? Here pi electrons only 2. So bond number is 1. So it is called as a aromatic. Whereas in the case 4 pi electron, here in the case 4 and 4. So these three are not, they are called as a anti-aromatic. Pi electron should be either 2 or 6 or it may number of maybe odd numbers 1, 3, 5. It is stable. Let us see the last question is which of the following question is same. Aromatic, same first compound is coming aromatic, whereas what is the problem with this compound? Here it is anti-aromatic because 4 pi electrons are there. Here the compound is non-aromatic, cyclic planar, but what happened? Your thing is here you are having the what is it? Non-cyclic. It is non-cyclic, so it is non-aromatic. Now coming here, what happened here is the electrons are going out, so it is also non-aromatic. So concluding, this is the AIMS 2017, it is the aromatic compound. Now comparing everything, comparison of stability, aromatic, non-aromatic and anti-aromatic. Anti-aromatic compounds are less stable and aromatic compounds are more stable, and this is the order of stability for the aromatic compound. Thank you children.